Imagine you had a magic notebook where you could only ever write new pages. No erasing, no whiteout, no oops, let me quietly fix that. And every time someone did try to sneak back and change something, the notebook basically jumped up and yelled, "Fake! Someone just tried to rewrite history." Now imagine that notebook isn't sitting on your desk. Instead, thousands of people around the world all have the exact same copy. They all keep it in sync, and there is no boss, no bank, no central authority in charge of it. That, in plain language, is the vibe of blockchain. People use it to move billions in cryptocurrency, trade goofy pictures of JPEG animals, track supply chains, and pitch questionable startup ideas in coffee shops. But what is a blockchain really? And is it just crypto hype? Is it an actually useful technology? Or is it one of those "it depends" answers? Today, we're going to take blockchain apart and put it back together so clearly that by the end, you'll be able to explain it to someone else without saying, it's like, the cloud, I guess? I'm Dr. Dude. Let's abide and get in it. So why should you care how blockchain works? Because whether you're into crypto or you think it's nonsense, the word blockchain is everywhere. You see, built on the blockchain, on-chain transactions, tokenized assets, DeFi protocols, supply chain on blockchain. You'll see it in job descriptions, conference talks, LinkedIn posts, random YouTube thumbnails with laser eyes, all of it. And yet if you ask, okay, but what is it? Half the time you get either a sales pitch or word salad. Some people say, well, blockchain will change everything. Others say, blockchain is useless and it's all scams. Most people are stuck in the middle, doing the polite nod. Yeah, blockchain, totally. I should Google that later. So here's what we're going to do in this video. We're going to answer 5 simple questions in human language. What problem was blockchain actually invented to solve? What is a block and why are they chained? How does a blockchain make it really hard to secretly change history? How do thousands of computers agree on one shared record without a boss? What is blockchain actually good for, and what is it not good for? Quick note, just like with the cryptocurrency video, this is about understanding the tech, not telling you what to invest in. This is not financial advice. This is how does the engine work advice. All right, let's start with something we all understand, a list. Imagine you and a bunch of friends run a tiny made-up economy. You don't use cash, you don't use an app. Instead, you have a shared notebook. Every time someone pays someone else, you write it down. Alex pays Jamie 5 credits for pizza. Jamie pays Sam 2 credits for homework help. Sam pays Alex 1 credit for a ride. Everybody can look at the notebook. It's your ledger, a record of who has what. At the end of the week, you can look back and figure out how many credits everyone should have. Now imagine that notebook is digital, just a file. At first, maybe one person keeps it updated. Everyone else trusts them. That's kind of like how banks work, but the bank has the master ledger. You trust them to update it correctly. If there's a mistake, you call them. There's a central authority. But what if you don't want that? What if you and your friends say, we don't want a bank? We don't want one person who can secretly change the file, delete transactions, or give themselves 1,000 credits on page 42? We want a system where everyone can verify the history, nobody can quietly rewrite it, and nobody is in charge of the ledger. That is the problem blockchain was created to help solve. So how do we go from a simple shared list of transactions to something that resists cheating? We don't store everything in one big blob, we store it in blocks. So what is a block? Think of a block as one page of that magic notebook. A block contains a few key things, a bunch of transactions, like who sent what to whom, some basic metadata, like a timestamp, a special digital fingerprint called a hash, and, this is important, the hash of the previous block. Line those up. Block 1, first batch of transactions. Block 2, second batch plus. By the way, here's the fingerprint of block 1. Block 3, third batch plus. Here's the fingerprint of block 2. Each block points back to the one before it. Put those together and surprise, you have a chain of blocks. Blockchain. Sometimes computer scientists actually name things sensibly. Right now you might be thinking, okay, cool, it's a linked list. Why is everyone yelling about this? The magic happens because of how those fingerprints, those hashes, work. Let's talk about hashing. A hash function is like a blender for data. You toss in any data, a sentence, a file, a list of transactions, and out comes a string of characters that looks random, like hello, 2CF24DBA5FB0A. Hello, 9595C9DF900B0. Even a tiny change in the input, adding 1 exclamation mark, produces a totally different output. There are three big properties that matter here. The same input always gives the same hash. Small change in input, huge change in hash. Given just the hash, it's practically impossible to recover the original data. So here's what we do in a blockchain. Take all the data in a block, the transactions, the timestamp, some other fields, and feed it into a hash function. That gives us a fingerprint, the hash of that block. We store that hash inside the block. Then when we make the next block, we include the new block's transactions plus the hash of the previous block. Now imagine someone tries to cheat. They go back to block 5 and change a little transaction to give themselves 100 extra coins. The data in block 5 changes, therefore its hash changes. But block 6 still says the previous block's hash is old value. Now block 6 is pointing to a hash that doesn't match what block 5 actually is anymore. Block 7 is pointing to the wrong hash of block 6, and the mismatch cascades down the chain. You've broken the fingerprint link from that block forward. So to hide your cheating, you'd have to change block 5, recalculate the hash, update block 6 to point at the new hash, recalculate block 6's hash, update block 7, and so on. You'd have to recompute hashes for every block after the one you touched. And remember, in real blockchains, hashes are tied to things like proof of work or proof of stake, which makes this very expensive to do. So the hash chain gives you a sort of tamper alarm. Change the past, and the alarm goes off in every block that follows. That's powerful even for a single copy of the chain. But now we'll make it more interesting. Imagine thousands of computers all storing and checking this same chain. In systems like Bitcoin or Ethereum, there isn't one central server holding the blockchain. Instead, there are lots of computers called nodes. Each node keeps a copy of the entire blockchain, listens for new transactions, checks if they follow the rules, listens for new blocks, checks if those blocks are valid. If they are, adds them to its copy of the chain. So instead of trusting one bank's ledger, you're trusting the network's ledger. If one random computer tries to sneak in a fake block, everyone else goes, nope, that doesn't follow the rules, and ignores it. But this raises a giant question. If there's no boss, no central bank, no main server, who gets to add the next block? How do we avoid chaos like, I think the next block is this one? No, I think it's that one. Actually, I'll just add my own custom money at the top, thanks. We need a way for all these nodes who don't necessarily trust each other to agree on which block comes next and what the official chain is. That's called the consensus problem. Blockchains solve the consensus problem using special rules called consensus mechanisms. The two big families you'll hear about are proof of work and proof of stake. Let's do the high-level versions. In proof of work, used by Bitcoin, there are special nodes called miners. Miners compete in a sort of global lottery. They're trying to find a value, a nonce, that makes the hash of the block satisfy some condition, like starting with a bunch of zeros. There's no clever shortcut. They just guess numbers and hash them with the block's data until one guess works. The more computing power you have, the more guesses you can make per second, the more lottery tickets you're effectively buying. If you're the first to find a valid solution, you shout to the network, hey, here's a new block and here's the proof. Other nodes check it. If it's valid and follows the rules, they add it to their chain. You get rewarded with some new coins plus transaction fees. Why does this secure the chain? Because to rewrite history, you'd have to go back to a past block you want to change, redo the work to find a valid hash for that block, redo the work for every block after it, and do all that faster than the rest of the network is creating new blocks. That means you'd need more hashing power than the rest of the network combined, which is insanely expensive in hardware and electricity. The cost of attacking the system becomes gigantic. You can punch the system, but you have to punch it with a mountain of money. That waste of electricity is part of the security model of proof of work. It's also why people criticize it for energy usage. In proof of stake, used by newer blockchains and modern Ethereum, you don't burn electricity, you lock up coins. Participants called validators put some of their cryptocurrency into a sort of security deposit called a stake. The network then does something like randomly choosing validators, weighted by how much they've staked, to propose new blocks and to vote on which blocks are valid. If they behave honestly and follow the protocol, they earn rewards. If they cheat, like trying to validate an invalid block, the protocol can take away part or all of their stake. That's called slashing. The idea is, you secure the network not by making it expensive to compute, but by making it expensive to misbehave. In both cases, the goal is the same: make it way more expensive to cheat than to just follow the rules. So now we've got a chain of blocks linked by hashes, copies of the chain on many computers, a consensus mechanism to decide which block is next, cryptography to secure transactions and signatures. So what is a blockchain really? What's the big aha idea you should walk away with? Here's the key insight. A blockchain is not AI, it's not magic, it's not the cloud. At its core, a blockchain is a shared, append-only, tamper-evident ledger maintained by a decentralized network using cryptography and incentives so that no single party can quietly rewrite history. That's the whole thing. Shared means lots of participants can see and verify the same record. Append-only means you only add new stuff, you don't secretly edit old entries. Tamper-evident means if someone does try to tamper, it's obvious. Ledger means it's a record of transactions, balances, ownership, whatever. Decentralized means no one person or company owns it. Cryptography and incentives means it's secured by math and economics rather than trust in a central authority. Emotionally, what does this give you? It gives you a new way to build trust. Traditionally, you trust banks to maintain account balances, governments to maintain land records, companies to maintain game items, loyalty points, digital goods, platforms to maintain who owns what online. When a system says we're on the blockchain, the claim is, instead of trusting us to keep the ledger honest, you can trust the open rules of this decentralized system. The history is visible, the rules are transparent, and changing the past is expensive and public. Now, reality check. That doesn't magically make humans honest. People still write bad code. People still launch scammy projects. People still lose passwords and get hacked. Blockchain doesn't replace human ethics. It just moves where trust lives. From I trust this bank/company/government to I trust that this network, following this set of open rules, makes it extremely hard for anyone to quietly cheat. Once you see blockchain as a trust machine for shared records, use cases start to make sense. Cryptocurrencies, who owns which coins, lives on this shared ledger. NFTs, who owns this unique digital item, lives on this shared ledger. DeFi protocols, who owes what to whom and under what conditions, lives on this shared ledger, enforced by code. Supply chain systems, where has this product been and who handled it, lives on this shared ledger, accessible to many companies at once. That doesn't mean everything needs a blockchain. In fact, most things don't. If you have one company using its own data, everyone already trusts that company. You don't need many independent parties to verify the same record. Then a normal database is simpler, cheaper, and faster. But when you have multiple parties who don't fully trust each other, all needing to read and write to the same ledger, and you want to make quiet tampering really hard, that's where blockchain starts to look interesting. So let's land this. What is blockchain? It's a way to bundle data into blocks, link those blocks with hashes so any tampering is obvious, distribute copies of that chain across many nodes, use a consensus mechanism like proof of work or proof of stake. So everyone agrees on one official version of history, and use cryptography so only the right people can sign transactions. The result is a ledger that's hard to quietly change, a system that doesn't need a central boss, and a new way for strangers to coordinate around shared data. What is blockchain good at? It's good at situations where you need a shared record that multiple parties can trust, don't want any one party to be in full control, care deeply that history cannot be quietly rewritten, and are okay paying some cost, complexity, performance fees for that tamper resistance and decentralization. What is blockchain not good at? Storing huge amounts of data cheaply. Super high speed, low fee, high volume transactions, at least not most chains today. Solving problems that already work fine with a simple database and a trusted admin. Magically making a bad idea good. Bad business model, but on the blockchain is still a bad business model. If you've made it this far, congratulations. You now understand the core idea of blockchain better than a lot of people using the word in PowerPoint slide. You don't have to be a blockchain believer. You don't have to be a hater. You can see it as what it really is, not a religion, not a joke. A very specific tool for building shared, tamper-evident records in a decentralized way. So the next time someone says, blockchain will revolutionize absolutely everything, or blockchain is useless garbage, you can smile and say, it's more complicated than that. Let me explain. In our earlier videos, we talked about artificial neural networks, how machines learn patterns, large language models, how they generate text, cryptocurrency, how digital money works on these networks. Today, We peeled back one more layer and looked at the blockchain engine underneath a lot of this. In the next video, we're going to build on this and talk about smart contracts, code that runs on the blockchain, decentralized apps, DApps, applications built on top of those contracts, and how people are trying to build an entire financial ecosystem. That runs more on code than on paperwork. If you enjoyed this, hit subscribe, give the video a like, and tell me in the comments which moment made your brain go, whoa, this video really tied the room together. I'm Dr. Dude, thanks for hanging out with me, and I'll catch you in the next one.